Okay, we are on lesson 2.2, properties from algebra. And I just took a picture of this from the book. Since the length of a segment is a real number and the measure of an angle is a real number, the facts about real numbers and equality that you learned in algebra can be used in your study of geometry. The properties of equality will be used the most often are listed below. So we have the addition property, which we use for equations. Just says if you have two things that are equal, if you add equal things to it, they will be equal. So if A is equal to B, you can add C and D to them because they're equal. Subtraction property is you can subtract the same thing from both sides and it'll be equal. Multiplication, you can multiply the same thing to both sides. Division, you can divide equal things by equal things and they'll be equal. Substitution property is kind of cool. If A equals B, then A or B can be substituted for the other into equation or inequality. Reflexive is like a mirror. Just think of a mirror it's looking exactly at the same thing. A equals A. Symmetric is you can just flip around the equal sign. So if you have 4 plus 1 equals 5, you can say 5 equals 4 plus 1. And the transitive property, if A equals B and B equals C, then A equals C. So if these two things match inside, if they're both equal to the same thing, then they're going to be equal to each other. And the same thing can be used for congruence. Congruence is you have to think of shapes lining up on top of each other. So if we're going to talk about DE like this, and we can say that it's congruent to DE. If you lay them on top of each other, ideally they would match totally. If we had, this would be segment DE is congruent to segment DE. When you're talking about congruence, you are going to put this line over top of it and you're going to read it segment DE, segment DE. If we had something like this, DE, and we have a 5 here, you would say equal to DE. So you would say DE equals DE because we're talking about measure, and that would be your equality properties. There's no line above the DE, and you would read it DE equals DE. This one's read segment DE is congruent to segment DE, and they're just talking about shapes. But it's the same properties as above. Reflexive, look in the mirror. Symmetric, you can flip the sides. And transitive, the middle two match, so the end two are equal. All right, let's try our first proof. This is kind of the heart of geometry is proofs, and it often takes people a little while to get them. So bear with yourself as you learn. So we're going to solve this equation just like you did in algebra, and you're going to put a reason why you can go from step 1 to step 2, from step 2 to step 3, and step 3 to step 4. So let's talk about what we're doing here. First, we're going to write down the given equation. The first step of a proof, you always write given. You're going to take what you're given and you're going to try to get to some endpoint. And in this case, we're going to try to get to the answer. So let's look and see, how did we get from step 1 to step 2? Well, it looks like we would multiply both sides by 2. And so when we do that, we're going to get to this. And so what happened here was called we're going to look at our properties. This is the multiplication property. And you can either write multiplication property, or you can just write multiplication, or you can actually just write mult like that. We're going to start abbreviating things because some of the things are really long and we have to come up with abbreviations. So let's see, how did you get from step 2 to step 3? Well, it looks like we added x to both sides. So we write down, how did you get from step 2 to step 3? We used addition. So you write addition, or you could write the addition property of equality. And then how do we get from step 3 to step 4? Well, we divided both sides by 7. And so we would write, to get from 3 to 4, we would write division. Or we could write div, or we could write the division property of equality. All right, that's an easy one because it's algebra. We're going to move to geometry, which is a whole different animal, as you guys have already discovered. Given, look how I'm reading this, segment RT and segment PQ intersecting at S, and I have the letters wrong on here, so let me just change these. They're going to intersect at S, and this letter is going to be a T down here. We are going in so that PS is equal to RS and ST is equal to SQ. We're going to prove that RT is congruent to PQ. This is a simple 4-step proof, but it's all new to you, so pay attention. First thing you want to do in a proof is draw the picture, but usually the picture will be drawn for you, the diagram. So what you're going to do is you're going to mark up the diagram. So I'm going to put little hashtags to show things are equal. So it says RS is equal to PS. So RS and PS are equal. And we're given that QS is equal to ST. So we marked up our diagram, and our goal is to prove that the two blue braces are equal to each other, those segments. So here we go. Remember, the first thing I said is we are going to write given, because we're writing the information down that we're given. If you can't do anything in the proof, because we're just beginners, they're going to start by just giving you some blanks. You don't have to do the whole thing yourself. You should mark up the diagram, you should write down the problem, and you should write the given, the minimum. All right, so RS equals PS. The next thing we can do is we can say, I'll write this down and then I will tell you what it means. I can't concentrate on talking while I write it down. Okay, so the next step is RS. At first they're going to give you all the statements and you just have to come up with the reasons, so don't panic. So RS plus ST, let's look at that. RS plus ST. So what we're doing is we're adding two segments together. We know that ST and SQ are congruent, so we're just adding, let me find them, RS and SQ. We're just adding equal parts to equal things, and so that's called our addition postulate property. So this is the same thing as if we had like 4 plus 1 equals 5, and we have 3 plus 1 equals 4. Never mind, that's just going to be complicated if I do this problem. You're adding equal things to equal parts. So let me just look at the property real quick. That might be the best thing to do. So the property says if A equals B and B equals C, then you can add this and this to both sides. So that's all we're doing here. So that's your addition property. Next thing we're going to do is we're going to use the segment addition property. We can say QS plus SP equals the big long part of it. So we're going to say RS plus ST equals RT, and we're going to say PS plus SQ equals PQ. So do you see what we did here? We said QS and SP, whoops, I didn't do that very good, equal the long segment. And this is called the segment addition postulate, and I wrote it down here. The segment addition postulate says you can add two segments together to get the whole segment if B is between them on the line. So that's what we have. S is between them, so we can add those together. And so this, we're reaching back into chapter 1. This is called the segment addition property. You can see how I'm abbreviating things. And then finally we can say RT equals PQ. See that? RT equals PQ, and that's our substitution property. Because these two parts are equal, right? I can substitute, instead of RS, RS is equal to RT, so I substituted that in there and got down here. And PQ is, since this is equal to PQ, I can put PQ here. And that's how we get down to there. All right, these are a little tricky. They mess with your brain a little bit because you're not used to thinking this way, but eventually you'll be able to understand these better. Let's do one more proof. This is with angles, so it's going to be the same thing. We're given angle AOC is equal to BOD. So first thing you want to do is you want to mark up your diagram. AOC, there it is. And with angles, we put a little arc and we put a line through it like that. Is equal to BOD. BOD. So I'm just going to go way out here. Whoa, my drawing looks awful. But these are congruent or equal. If you're going to say with angles, remember how we talked about, we would say like AB equals CD, or we'd say segment AB is congruent to segment CD. With angles, we say measure of angle A equals the measure of angle B, or we would just say angle A is congruent to angle B. So when you're using congruence, we're not talking about measure, because remember, congruence is just shape sizes on top of each other. So let's rush through this one a little bit. We'll go over this in class tomorrow. This is your statement, and this is your reasons. So our first thing we do, remember what we do for the first step, is we just write our given down. And we write given. Now really, when you're doing a proof, you have to look at the end where you're trying to go and think of logical steps. It's kind of like a computer program. This is really helpful if you're going to be a computer programmer. I don't know if anyone will be, to think logically from getting to one step, what you're given, to an end result, being able to justify each step along the way. The next step, they'll probably give these to you in the book, is the measure of angle AOC equals the measure of angle 1 plus the measure of angle 2, and the measure of angle BOD equals the measure of angle 2 plus the measure of angle 3. And that reason, let's look at the diagram, AOC is equal to 1 and 2. And that's just your angle addition property, similar to your segment addition property. These two angles add up to this larger angle. So this is the segment addition property. We'll be using several of these over and over again until it burns into your brain, most likely. All right, so we have that. Now we can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And if you look up here, we know that AOC equals 1 plus 2. So we can substitute. This is called substitution. We're going to take this and we're substituting it into that, because we know that AOC equals 1 plus 2, and we know that BOD equals 2 plus 3, so we can substitute in there, and we can say that those are equal. And that's just substitution. And then finally, this is a 5-step proof. We can say measure of angle 2 equals the measure of angle 2. And the reason for that is reflexive. Remember, that's that mirror thing. And then finally, because 2 is equal to 2, which seems like a really redundant step, I think later we start leaving that out, we can subtract this from both sides and just say the measure of angle 1 is equal to the measure of angle 3, because we're taking off the 2's, we're subtracting it from both sides because they're equal, as demonstrated by that step, and we would say subtraction. Oops, I spelled it right the first time. Subtraction property. And so we proved that measure of angle 1 is equal to the measure of angle 3. Now, this is going to seem really foreign to you to do these proofs. We'll probably end up doing most of the proofs in class tomorrow in your homework, but I want you to try them all. It looks like they give you most of the steps, and you just have to come up for reasons how you get from step 1 to step 2, step 2 to step 3. So I'm going to end the video here. Tomorrow we're going to go over all the homework from sections 1 and 2 in detail. And if we have to do videos, the next time we'll do videos. And also I'm going to try to see if we can get all of our classes live, and we'll have Aaron Skype in. So that's it for lesson 2.2.